here to learn about debugging Java. I guess we're all Java programmers. Have frustrating bugs to track down. My hope is to give you some ideas, insights, and tools and techniques to help you do this a little bit better. I've been programming Java for almost 30 years and have a lot of fun with it. And I've learned a couple of things along the way. I currently support a 20-year-old Java desktop swing application. So, yeah, I spend most of my time debugging. Let's go. Come on. Help me out here. Okay, so there was a study done in 2002 that compared the best developers of a team with the rest of the team. And it turns out that the best developer of the team will find bugs in a third of the time it takes the rest of the team, and they'll create less than half as many bugs as the rest of the team. So we're going to aim for being one of the best, right? I mean, that's why you're here. The fact that you're here means that you're already among the top developers. Just out of curiosity, is it just me? Does anybody else have work in a team where you're the only one who goes to conferences and reads books and that sort of thing? Is it just me? I guess it's just me. Wow. Y'all work some amazing companies. I want to find out where you work. So effectively, we want to be the best in reporting bugs. Have you ever gotten a really bad bug report? My first job out of college, I was doing documentation, and so I had written up the documentation for this. We were going to have some people from the company had taken time to go and evaluate the software, and the only comment I got was, "What little was written was wrong." This is not helpful. I then found out later that, unbeknownst to me, someone had, in between the login page and the dashboard page, someone had added a special page with links to take you to, how to get to specific features you might want to go to as a favor. It's like, well, it would be good to let people know, especially the guy who's writing the docs. So, yeah, you do want to get better feedback than that. You want to be good at testing. You want to be the best at testing in your team because it keeps you from having as many bugs. And then for the things that you didn't think of, that's why we have the bug hunting. You want to be excellent at that. And you need to know how to use your tools to do that sort of thing. Now, ideally, what you're going to do when you're testing, when you find a bug, you want to write a test to reproduce that bug. Because if your software is like mine, the bug is somewhere deep down in there. So I've got to log on, I've got to open the file, I've got to click this button, I've got to go to that page, got to go to that tab, got to open this. And then I click this button and I type this in, and then it does something strange, which I can do. But if I have to do it 15 times, then half the time I'm going to click the wrong thing, and then I got to go back, and then I got to go and restart it all over again. And it takes a whole lot of time. If you can automate it for just recreating that one bug, that can save you hours in tracking it down. And for free, you now have a regression test to make sure that sucker doesn't come up again. So one other thing that's really important is you need to have one of these. You need to have a journal. I keep this journal right next to my mouse on my desk, and I write down the thoughts that I have as I'm developing. Oh, we ought to add this feature. Oh, I've tried this. Let me try that. This is the piece of data that I need to type in to make sure I get to the right place. Having that right there next to you is so incredibly helpful. And then a couple of weeks later, when that bug comes up again, you can just flip back and say, oh yeah, these are the things that I used to reproduce it, and that's still working, so I need to change this part of it to make it now create this new bug that's really related. So if you think about it, it's kind of like Wordle. You know how you got the gold means that it's the right letter in the wrong place, and the green means it's the right letter in the right place. If you don't have that history, the game is useless. So use this as your history. Keep a document right next to you. Keep a journal. And I know what you're saying. I got work to do. I can't be writing all this crap down. I can't go and automate every doggone bug that I run into. I got to get things done. Well, the fact of the matter is, even Google has the I feel lucky button. So you can do a quick and dirty couple of tries and see if I got it. And that's great. But if you're spending more than, say, 10 minutes doing quick and dirty tries, it's no longer quick, it's just dirty. So go ahead and invest the time to automate it, okay? Now I know why you're here. You want to know about the debugger and how to be more effective with the debugger, right? So the thing is that we tend to jump into the debugger right away and just start stepping until we get to the place where we want to get to. It's important. You can waste a whole lot of time on the debugger. And it's important to, before you just jump in and start doing this, the step, look at the variable, step. You figure out, how does the debugger work? Use the keystrokes to move you forward or to jump over things and that sort of thing. I'm going to talk about that. But it's important to know where to start. Otherwise, you're like the guy looking for the keys under the light because the light's better there. It's not going to get you there. You want to know where to start, know what section. I've got the stack trace. That's a great place to start. Okay, I can look from that point. Okay, I can see what value was set in the wrong way. Okay, where was this value initially set? So I need to go to where that point is and just jump right to that point and then start stepping, because it's easy to just turn off your brain and step. Say, oh, missed it. All right, let's start it all over again. Click, open file, open. Yeah, you want to maximize your time. It's so much more fun when. Doesn't it feel good when you figure out what caused that bug? Okay, sometimes it's like, oh, why did I do that? But a lot of times it just feels so good when you figure out what caused that doggone bug, and you're eager to show off that big S on your chest and say, okay, I'm ready for the next one. Bulletproof. You want to go to the stack trace. You want to see, in this application that I support, I've got dozens and dozens of pop-up windows, and I have no idea who created this pop-up window or where it is in the application. So I look for any kind of identifying features, a title on that window, or is it the text that's in it? I can figure out where that text got set and then figure out, okay, or a menu item that brought that up. So that's a good way to find where you're going. If you have some unexpected output, okay, so maybe see where the prompt is for that and search for that and get to that point. Or even if you've got corrupted data being written out, okay, what is the function that writes that out? Let's step back from that point. So, did anybody go to Tracy G's session on using IntelliJ more effectively? Excellent. I tell you what, I went to that last year, and halfway through, I purchased her ebook because it's like, this is worth the price of entry, all the cool things she showed us. So I'm going to quickly go over some of the things that she showed us that are really cool for those of us who didn't go. Right? So let me just close that. There we go. And I bring up my little program. Is this big enough to see? Okay. All right, so I'm going to show you some of the cool features of IntelliJ that can help you. How many of y'all are IntelliJ users? Okay. Who does Eclipse? All right, then we won't worry about it. NetBeans? Oh, break my heart. Okay, nobody uses NetBeans anymore. I love NetBeans. Okay, so the first thing I want to show you is, let's see, evaluating a dialog, the evaluation dialog. So I've got this program, does a merge sort, and right, so I've got it here, and I will just say, let's go ahead and debug this. So I say, right-click on that and debug it. I have to do it this way because if I just push the key, then it'll go to what the default is up here, and I don't want it to. So here I am. I've got this function, and I don't know. I can hover over left and see what it is, or I can see what left and right are right over here, which is pretty cool. It's an array list. I can see what that is. That's nice. I can also say, what will this function call do? So I can highlight that, and then I click this little calculator-looking thing. That's the evaluate expression button. And I can just say, okay, evaluate it. Oh, look, it sorts it. Pretty nice. And it will give me the results. And I can say that, you know, what if I want to change something about that? So I can say, you know, I want to see what the size is. So I can type in effectively anything I want to here, which is really cool. And for instance, if I go to like here, and I decide that I want to look at I, and I don't really want it to be 0. I can go to the evaluation dialog, evaluate expression. I'm going to say I right now evaluates to 0, but I want I to actually equal 1. Okay? So now you can see right here, I equals 1. I've just changed it in the evaluation dialog, which can be pretty doggone handy. And then I can say, oh wait, no, I didn't mean to do that. I've screwed something up. I've stepped too far. I really wanted to go back. You can go right here. See this little back arrow? This goes and resets the frame back to before this function was called. How many times have you stepped past something you had to start all over? I didn't know this existed. This is why I bought that doggone book. Right here, you see how it's got this little back arrow in front of each part of the call stack? You just click that little puppy and you can go back to where it was before it made that function call, which is really handy. Now, if you've got class variables that you set within that function call, then those are still going to be set that way. But it can save you hours of debugging. It's tremendously helpful. One other thing I wanted to show on the evaluation dialog. So I go, come on. I right-click, go to evaluate expression. So have you ever needed to get a system variable, but you didn't know what it was called? What is that doggone thing? You can just say system.get properties. It's like, what is the property that I want? I don't know. Well, this will tell you what all of them are. Come on. So what is the one for putting the carriage return in? Oh yeah, it's line.separator. All right, I'll put that in. So, you know, what is my Java version, my OS version, Java version? I got all that stuff right there. That's a huge time saver too. So yeah, that evaluate expression is really handy. I use it all the time. You can also use the what's that thing called? See, I clearly don't use it much. Or the J shell to do this sort of thing. So if you're constantly having to go back to the evaluate expression, then you can just set up the J shell to do that. But The evaluate expression is nice because it's a window and it goes away and you don't have to see it when you're done. What else? Okay, so in the debug panel, you can, for instance, I've got this here, I've got these breakpoints all over the place and they keep stopping and I'm wanting to just get to this point. What I can do is say I want to get here and I don't want to stop there. I can get this out the way. I see where, right here, dot, dot, dot. So I can say, I want to force run to the cursor. So I'll set my cursor right here, and I'll say force run to the cursor, and it doesn't stop at any other breakpoints in between. I'm one of those crazy guys. I have, I don't know, probably close to 100 breakpoints set throughout my code because I'm always going to this little section and I'm always going to that little section. And it's very frustrating. And sometimes I just want to get right here. And I don't want to go through 37 breakpoints along the way. This is another incredible time saver. Also, you see that this is like a diamond. This is a method breakpoint. So it will stop as soon as you reach the beginning of the method. And this is just a line breakpoint. Now here, you see it's got a little question mark on it. That's because this is a breakpoint that's got a condition. So basically when mid equals 3 is when it's going to stop there. And it's going to continue until this mid equals 3. So what I can do is I can disable this one and disable this one and then just say go, which is F9. And, oh, I guess it didn't get there. Let's just try it again. There we go. So it just runs until it gets to that point, and you can see that mid at this point equals 3. Right there. Pretty cool. So this is a watch that was put there automatically because it's just a local variable for the method. But another thing you can do is, this is real simple, so I don't have it. So what you do is you right-click on the breakpoint, and then you can enable it. You can tell it to suspend. You can also say, don't suspend. Keep the breakpoint there. Keep it active, but don't suspend. Just let it continue because I want to count. And let me show you how you do that. But yeah, you can set the condition here, and then if I don't want to use the condition anymore, I can just disable the condition, and it stays there. Then you got all this fancy stuff that you can do if you want more. So what you can do, like I said, you don't want to necessarily stop there. You can do a pass count. So I want to count the number of times that it's passed this as I'm going through. Sometimes you're just stepping through, and on the 47th time through is when the bad data gets stuck in there. Right? Right? Yeah. And so you can sit here and say go 47 times, or you can say, do it 47 times. Pass count is 47, 37, whatever, and it'll do that. And then on the 37th time, it will stop. And that can be really handy. You can do the condition. You can make the condition as complex as you want. You can have it log every time it gets to this breakpoint, not stop. That can be handy too, because you can see, okay, what led to this going wrong? So, because my value is true, and all of a sudden it's false. Or it's red, and all of a sudden it turns into hound dog. Wait a second, that doesn't even make sense here. So another thing that I do a lot is, since I have a lot of breakpoints, you can create groups of breakpoints. And then I can say, okay, I'm just going to turn all these off for now. So for instance, in my application, we've got 13 different places where we will write data out to the database. And I want to know what that query is. when I get there. So I have a breakpoint there right till I see what the query is before it gets run, and that's handy. But I don't want to do that for everything that I'm doing. It's just in the bug that I'm looking for. So I'll go in there and I'll just disable all the breakpoints for the SQL queries until I get to the one that I want. And then I'll come back and I'll turn it on and get to that. So that can be really handy. So you can go and create your own Java, no, not method breakpoints. I want to create my own group of breakpoints. Call this is my special breakpoints. So, anyway, but and then you can break on an exception. I wanted to, what threw this exception? Yeah, I've got the stack trace, but it takes me to where this exception was thrown, which is where it was caught. But that exception happened deep down in the code somewhere, and I've lost where that is. I've got to go and find my way down. Well, I can break on when that exception is thrown, and it'll be right there in the code before the exception gets thrown, and we're popped back out to my exception handler. Yes, sir.
Do you have sometimes I do that, and like if it's like for a class not found exception or null pointer exception that just happen all the time in libraries and things like that, I find it like very difficult to find the one that I actually care about.
Yeah.
Do you have any advice for that? Like a filter or something?
Yeah. So it throws multiple exceptions, is what you're saying? Multiple of the same exception.
Like just like in the normal startup of the Java application, like the class.
Right. Okay. Yeah. Right. Is it on startup that you care about it, or because you can like turn off the disable all the breakpoints until you get to that point. I have a similar situation when I start my application up. The company has inserted some special library on the class path, and it conflicts with whatever version of Java that I'm using, and so it complains every single time. And so, yeah, I kind of just endure that. I'm sorry, I don't have a good answer for, unless it's a special exception. Well, I guess, select a breakpoint. So, yeah, we'll turn this back on. And, so you can set the exception, but you can also evaluate. Where did the exception thing go? Java exception breakpoints. Here we go. Any exception. All right. So you can break on the exception, disable until hitting the following breakpoint. Yeah, so that might be good. You can set a breakpoint before that point. And you can also set a condition that, okay, I'm getting this null pointer exception when, on startup, but it's after this has been initialized. So I can set that there if you have some idea on that. So you can put the combinations of stuff in there, or you can say, the fifth time it always throws a stupid exception, and I can, have the pass count set. So you can combine these to be clever enough to help you. Yes, sir. Oh, yes.
It almost makes me feel like I wanted to force on to stop on the thread breakpoint, but it doesn't always seem to want to stop.
Yeah. When you're debugging multi-threaded stuff, that takes a special kind of patience. And yeah, I hear you. Sometimes the thread will be someplace and I don't know what's going on. Why am I way deep down in this mess of Java library calls when I should be in my code, and when I pop up to the top, it's nowhere near anything that should be running. Yeah. So all I can say is I feel your pain. Multi-threaded stuff, really, it's like duck sexing. You just kind of have to, or chicken sexing, you kind of have to know how to do it and develop a sense for it. What else do I want to show you? Covered all this. Watches, traces. Okay, yeah. Oh, yeah. So this is the other thing that oh, come on, what's her name? I'm drawing a blank now. Tracy. Gee whiz, don't let her know I forgot her name. Tracy was showing that just blew me away. So let's say you're running this here Lambda program. And I've got this Lambda expression that's with the streams and everything, and I'm if you got a Lambda expression, you set a breakpoint there. You see, I got a breakpoint right in the middle of the freaking Lambda, so I can partially evaluate the Lambda and see what that looks like, which is pretty darn cool. But look at this. You go down to this here little 3 dots. This is where your magic menu is, and you can say, I want to see what this trace the current stream chain would look like. So what that does, flat mode is less dramatic. Here's much more interesting. It goes through and shows you at every step along the way what it's doing as it's evaluating the streams in the Lambda expression, which is so insanely cool. So you see that what I'm trying to do here, first I'm going to go for every car, every one that's black, I'm going to map it so that it'll print out just the brand and the model, and then print those out. Okay, so you can see here that there's lots of different colors, and then you look at all of these are all the black ones. And then it will go and print out, it'll go and map it to just the name and the model, which is so insanely cool. Which is nice. Yes, right here. I call this the magic menu. This is in your debug window, all right? And it's at the top of your call stack, and you click on this, and you go to Trace Current Stream Chain. You've also got the evaluate expression there, but you do the Trace Current Stream Chain, and it will go and evaluate the whole stream. And if you want to see it in detail, you can flatten it out, say, okay, this is what I started with. My filter goes and gives me this, and then my map is going to go from that filter to this, and then the for each doesn't give me anything because it's just printing it out. But it's okay. So you see how split mode has every step along the way, and it's all kind of mashed into one window. But I have to go and hover over everything to see it. If I put it in flat mode, then I can see it more clearly. Correct. Yes. Yes, sir.
How did you get the breakpoint inside Lambda again?
I just set a breakpoint right here at the beginning of the Lambda. And then here, I'll disable that. You can see that as you hover over this, there's a little red dot. Can you see that little? It's a very faint red dot that's in the middle there. So by setting a breakpoint at the beginning of it, you can get a breakpoint in the middle of the Lambda too. And so you can see either the beginning or the first step in. How many times have you been saying, why is this not evaluating the way it should? That is so intensely frustrating. I can't figure it out, and now you can. Oh my gosh, it's amazing. Okay, so that. And another thing that is really cool that I like to show off here, it comes in handy especially here with this kind of stuff, is I have, if you right-click on this value, you can go here and say View As, and you can create a renderer. So you can see that by default, this is just going to show the stuff that's in that that's in there. all the members of the object. And so what I did is I created a renderer that says I'm going to go format a string, so it's going to have the brand and then the model and then the color. So it's not going to say lambda car brand equals lambda and color equal and model equals. So this just goes and prints it out. So it just makes it easier to read. And what else? Do all kinds of stuff. So yeah, you can put all kinds of expressions in there to make it more useful. And then you apply it, and there you go. Sometimes you have to go and refresh it, but yeah, this makes it easier to read, and it's nice that way. Okay, and of course you can also put the renderers over here so that if you've got sometimes it'll display. It uses by default the toString function, whatever the result of that is, which may or may not be useful, especially if you've got like an array. So I can then just go here and I can say, where's the view as create render. So I can tell the array to I don't know, whatever. I didn't prepare something for that, but you can have it go and say I want to get the length of it, or I want to get the first two entries in that, because those are the two that are more that concern me the most. So anyhow, so these are some debugging things that I find really helpful, really handy, and save you a whole lot of time in the debugger. So, what is another thing that we spend a lot of time wasting, a lot of time trying to track down, is our memory leaks. You don't get them enough that you've mastered the tools to track them down, but you get them every now and then, and they're really frustrating, especially if you're working on somebody else's awful legacy code. Nothing I would write would ever have a memory leak, but someone else wrote some really crappy stuff. So what we do is, let's see. Actually, here we go. Got to use the right notes in the right order. Okay, so we got this. So what we have is this tool that's called Visual VM. Have you all heard of this? It's free and it's handy, and it'll just show you what memory looks like. And so what you can do is I'll just run my memory leak example, and you can see that it's going creating a bunch of stuff. And I just go here and find my memory leak example. I know you can't see it, but it's right there. All right, and I'll just open that. And then I can go to the monitor and say, do a heap dump. Boom. Now, so here's the deal. I can do a heap dump from within IntelliJ. But the thing is, I have to start debugging, and then I have to set a breakpoint here. And come on, set a breakpoint there. All right, and now I can go to over here in this little thing. I can turn on the memory window, and then once I hit the breakpoint, I tell it to load the classes. So then it'll kind of do a heap dump, so I can see what the classes all look like. I see, okay, yeah, this resolve module is the one that I happen to have the most of. But if I go to Visual VM, I can go to my heap dump button, and then so yeah, I go to heap dump, and then I can say, okay, I'll look at the things that I have in here. So I know you can't see this, but it says view all. So I look at all those, and I can say, okay, so this is, I got, almost 200 megabytes of stuff here. And what the heck is that? and a bunch of bytes. These are all 1024 items. Hey, if I look back at my code, I can see that I'm going through and creating 1024 byte entries into this array. So if I look at this and look at my references, I know you can't see that either. So we'll zoom in. So items, references. Yeah, that's the only problem with this. The font is so tiny small. Hash map node, I can just...
So it does not show where you're creating, or?
Well, it shows the object. Basically, you can look up the list and see the object that is creating the trouble for you. So you see we got this, it's in this hash map, and it's, this happens to be number 1088 in the hash map, and then there's a static cache. So that static cache seems to be the object that is creating my problems. So then I can go back here and say, okay, here's my static cache entry, and I'm adding it every time, and then I'm not getting rid of it, and it's just kind of hanging around. Oh, this is a static cache, so that means garbage collection is never going to get rid of it.
Do you know if there's any tooling that's available for when you have the Java application that's running as a native executable that's usable?
How to debug a native?
Yeah, like to be able to have a memory dump that's usable in the same way as it is for like Visual VM. Like, does Visual VM support that?
Visual VM will attach to a running process. Okay, so you can see that I could do a dump on IntelliJ. I can do a dump on Visual VM itself. So if it's a Java executable, you can attach. This is showing all the processes that are running in my program right now. In my computer.
I'm referring to when you use like VM to produce it.
Right. Okay.
Still possible with Visual VM, or because I understood it as like requiring an actual JVM running, which.
Well, I mean, even if it's an executable, it's got a JVM kind of packaged in there with it. Okay. So Visual VM will. I mean, this is an executable. So I mean, I can go to Visual VM, go to monitor, and I can do a heap dump on Visual VM too. And then I can see all the variables that are running inside that. Does that help? Yeah. Okay. Yeah. It's a powerful tool, especially with as inexpensive as it is. It's amazing.
Thank you.
Visual VM is a separate application.
Yeah, it's a separate application. I'll show you the links to everything later. It's on my slides. So and I'll get you the link to my slides. My GitHub is Scott Bob, because I'm from Texas, and this is the Devnexus 2025 branch inside there. It's got all my slides and the code and links to the stuff I'm going to be talking about. Yes. It is running remote. That is a really good question. I have not done that. It's got the ability to connect remote. Okay. Yeah. Thank you. Yeah, I've honestly I haven't tried that yet. But anyhow. So basically, what you would need to do in a case like this, where you find you got a static array that's never going to get garbage collected, is that you need to go through and clean it up from time to time. So okay, find what's not being used and do your own cleanup. There's also listeners. Let me go ahead and kill what I've got running here. Stop everything. All right. So, yes, sir.
I think I missed earlier. You were stopped on a breakpoint when you connected with Visual VM.
No, I was not. That I was showing you that one of the limitations, because IntelliJ will show you where you're at in this memory window down here on the bottom right. But you have to stop at a breakpoint and then tell it to collect all the objects, which, I mean, it's great having it handy right there, but Visual VM does it while it's running live. And I can just do a heap dump right there and see what's going on without having to stop the application, which it just saves you some time there if you got the application installed. Well, whatever running, you don't really install it. I work on a Swing application, and it's event-driven. You probably are working on Spring applications, which is event-driven. So we've got listeners for whatever stuff is going on, and a lot of times we will create a listener and then, it's going to retain a reference to the object. See, I was practicing this, and so now I need to go and uncomment the bad stuff and put the good stuff back in. Give me just a second. Pay no attention to the man behind the curtain. Come on. Live coding is hard. Just so you know. Okay. All right. So, you see I've got this thingy record, just so that I don't have to use an object. And I'm going to go and I'm going to create a new thingy, and I'm going to add it, and then I'm going to sleep for 100 seconds. I'm going to just register all these listeners, but when I drop out of scope, that listener is still registered because it's in whatever the registry is. And so, I can run it, go to my listener leak example. I know you can't see that. And I can look at this, and I see how my space is going. Look at the heap dump, and I can see that I've got, where is it? References. Dump. Group of, here we go. Sorry. Yeah, classes by number of instances. And then we can go in here, view all, and I can say, I'm going to filter by thingy. And I can see that I've got 142. All right, so, and okay, looks like we've done a garbage collection. So I'll go do another heap dump. And I will look at my classes, see how many thingies I have. And I've got 566. Wait a second. I went from 142 to 566, even after a garbage collection. So these are being hung on to. So you have to make sure when you are creating a listener that you clean it up. And again, the solution to that is to have some code that goes and does garbage collection on that. And come on. There we go, right there. And so you can see that, like here what I'm going to do is just I'm going to run through and clean up the listeners. So I'll run it again. Boom. And this time, when I go into Visual VM and I listen, watch it, go to my monitor, do a heap dump, go look at everything, see how many thingies I have. I've only got 6. Well, that's okay. And then I can go back to my monitor tab, see what we got. We did a garbage collection, and then I can go back in here, see all my thingies. Come on. And now I got 5. So my number is actually going down. So that's kind of nice. And it's a small number anyway, so that leak isn't creating as much of a problem because I'm going through and cleaning up after myself. Like I don't need this many listeners or this many instances of the listener around. And if you are a Spring programmer Phil Webb is doing a session on debugging Spring that I'd recommend you go to because he'll give you much more in-depth stuff than I'm showing you here. So basically, to avoid your memory leaks, you're going to want to make sure you unregister your listeners. You don't want to use static collections of things because that'll just grow forever. And just validate your code every now and then with a tool like Virtual VM to make sure that you're not getting leaks. And watch out for your finalizers and your other cleanup code to make sure that it's doing what you think it's doing. Because those other guys who write that bad code, they can leave in problematic stuff like that. So, okay, so we will go. Is that it? Yes, I did it right. Okay. So for people who are using Eclipse, these are how you can do conditional breakpoints and the different ways that you can set them up. Would any Eclipse users here care? No? Okay. Then I'll just flip through that. So other tools that you can use to look at heap dumps or look at memory. Eclipse has the memory analyzer, MAT. There's also the Java flight recorder that comes with the JVM. And who's doing the session on the Java flight recorder? Well, there's a Java flight recorder session this weekend, this week, so check it out. One important thing is ask for help. A lot of times, tracking these kinds of bugs down are really hard. And you can ask have you asked your rubber ducky? And ask somebody. Just sometimes explaining it just makes all the difference in the world. You can explain it to your mom if you want to, and just trying to put it in terms that she would understand makes you all of a sudden say, "Oh, I know where the problem is." Yeah, and so I don't know if you know Bruno Souza. He has a saying that you think you're thinking when you're thinking, but you're really thinking when you're talking or writing something down because it forces you to clarify your thoughts. One more vote in favor of the old notebook. And like most things, like your threading issue, experience helps a lot. You sometimes just gotta power through it and see the nuances of how do I solve this kind of a problem. And if you don't have that experience, borrow that experience from someone who has fought this kind of problem before. I used to do C programming a long time ago, and there was this great book by the great Andrew Koenig, C Traps and Pitfalls, pointing out all the problems that even experienced C developers run into. What do you think the first thing is in that book? No. Doing a comparison, doing an assignment inside of an if statement. That's why Java doesn't allow it. I mean, I can't tell you how many times that's bitten me. And it bites me all the time in Java still. So if you're C++, there's now the 100 C++ mistakes. Manning just came out with that, but we're Java developers, so there's, of course, the 100 Java mistakes that you want to avoid. Manning has got some really good books come out lately. If you want to go into more depth of, more like how to handle memory leaks, how to handle concurrency problems and that sort of thing, this, what's his name, Laurențiu Spilcă has written this book, Troubleshooting Java. He's coming out with a new one, so you can get the MEAP, which will get you this one for free. And he's showing how to use AI to assist in helping to debug stuff. I highly recommend this book. And then, of course, to prevent you from getting into these kind of problems, this is just a good book to have read so that you know the best way to do things. This will help you to avoid a lot of the bugs, or if you do come across a bug, this is how you can get it cleaned up. So, and one thing I want to point out, you don't improve during a performance, all right? You improve when you practice. So you want to make sure that you're ready when you're on stage. And so when we're at work working, we're generally not practicing. So you need to set aside some time to practice these techniques and tools and learn about stuff. And that's why you're coming to this conference, so you can learn more stuff and practice. So set aside some time. It might be good to have you got a workout buddy to help you exercise. Have a workout buddy to help you practice new stuff. So that's something I would strongly recommend. One thing begging the question of being a master debugger is, do you really want to be a master debugger? Because as one of my very wise managers told me, if you get good at solving this kind of problem, you're going to get more of this kind of problem to solve. Because you'll be the go-to guy for this kind of problem. Ideally, you want to learn how to program in such a way that you don't have to solve these kinds of problems. You want to write quality code, and you want to help your team to learn how to write higher quality code. Okay, so I abbreviated my session, and it looks like I didn't need to. But this is how you can get a hold of me. Anyone who knows anything about me, I'm all about refactoring code. So I've got a book on code smells and how to handle those things better. If you want to keep in touch with me, there's many ways to do that. And if you want the slides and the links to all the books and the tools that I showed you here, that's a more complex QR code, but it'll get you there. And then this is the link that it takes you to. It's basically, you find me on GitHub, Devnexus 2025. I'm Scott Bob. I can show you some other cool stuff. Yes?
Can you talk more about threading issues? Like more often than not, I see threads are stuck. I don't know why they are stuck. Suddenly the application performs slow. If you want to figure out why is it slow, which thread is stuck, which thread is doing what.
Right. So, all right. I am not a master threading issue debugger. I will tell you, I've gone through and let me see. Do I have? I've got this guy's book here, and so I go to Troubleshooting Java, and I think his multi-threading. Get the book. Multi-threading is in chapter 10, I believe. Multi-threaded is chapter 9. So let's look at an example from chapter 9. I did not prepare this, so this will be live coding in the scariest way. Sure. Well, does anyone have any other questions? Because it will be interesting to learn this together. So the thing I do know, Troubleshooting Java, chapter 9, example. We'll try, let's try this one, see what happens. Yeah, kill whatever's running. So what we got here, we have a consumer, we have a main. Oh man, sorry about that, thank you. Now we can get rid of this. And then we go back to this. Right. So basically you have the main, which is going to have a producer, and then a consumer, right? So what we'll do, we'll just run our main. This is more about discovering that you have a problem. So we're going to let that run, and then I come here to Where is it? Remote Maven server and release main. Well, I guess that would work. There we go. Oh, it went away. Did it die? It finished. I'm not fast enough. All right, let's try it again. Okay, so I go to main, and then I can go and monitor, and I can see that. And then this will also show you all the threads, and you can see how they're growing. You see that consumer and producer seem to be growing a lot, and then it just dies. Right? So it looks like we run for some period of time, and then it dies. So how do I track down threading problems? I need to have this not die. Sleep 10,000. I can have this, I'll add a 0. Add a 0. We'll run that. We'll debug it. And now what I can do is I can set a breakpoint in here. No, I need to go to producer. Set a breakpoint in here. Nope. Somewhere in here it's got to stop, right? Is it running? Yeah, it's creating a million of them. Maybe I had too many zeros. There we go. All right, so we'll need to run this a few times through. So our producer is going to have all this stuff. Yeah, we're supposed to have our call stack, which will help us. Threads and variables. Yeah, let's just run it and see where it gets us. Yeah. So yeah, I do not. I'm sorry, I'm not much help with the multi-threading thing. I'm going to just have to leave it at that. But yeah, I hope you found some useful tips and tricks in debugging and some useful tools that'll help you do this better. And maybe what's his name, Phil Webb, will have some better ideas for multi-threading because Spring is dealing with that a lot. So that's all I have to say about that. Y'all have a great rest of your conference.